Hello there, welcome to this video on graphing sine and cosine functions with amplitude and midline. For this video so far in Math 3, you guys have dealt with just graphing sine and cosine with amplitude, but now we're going to go ahead and throw in a term called a midline by adding a constant function to our functions, which is just going to move our graphs up and down. And so we'll go ahead and talk about that. Our objective for this video is students will find the amplitude and midline of a given function and graph it, as well as write equations given amplitude and midline. So remember that the amplitude of functions is always the a value that is out front. So here I have a couple of functions, y equals a sine of theta, as well as y equals a cosine of theta, and the amplitude is just the absolute value of that number. Okay, and this just tells us, right, how far up am I going to go, how far down am I going to go. Now, likewise, similarly with the a value, a multiplier out front, if it's negative, it's always going to cause our graph to have a vertical reflection or an x-axis reflection. Okay, so just kind of recapping here, it says write an equation of the sine function with an amplitude of 2. Okay, well, I know that the function is sine, and I know I have an amplitude of 2, right? So if I have to write a function of this value, right, y equals a sine of theta, well, I know that a, the amplitude, is 2. So this is just going to be y is equal to 2 sine theta. And that's it. Very, very simple. Second example, write an equation of the sine function with an amplitude of -3. Okay, so following the same idea, right? Y is equal to, okay, my amplitude is -3. My a value is -3. Amplitude really is positive. It would be +3 with an x-axis reflection. So I kind of don't like the wording here, but it's y equals -3 sine theta. Fairly straightforward, right? They give you an amplitude, you stick it out front as a multiplier in front of whatever function they say. Okay, so here is two practice examples. So it says write an equation of a cosine function with an amplitude of 9, and then the second one, write an equation with the sine function with an amplitude of -23. Please go ahead, pause the video, try these two examples, and I'm going to post the solutions. Okay, hopefully you have tried these. Here is the solutions. Okay, y equals 9 cosine theta, fairly straightforward, and y equals -23 sine theta. All right, so now let's go ahead and weave in the new material that we've been talking about that I kind of alluded to, and that is adding in a vertical shift, a k value. So here is the general function. Y equals plus or minus a sine theta plus k. And this plus k is your vertical shift, okay? That's the vertical shift. And if it's positive, it's going upwards. If it's negative, it's going downwards, and this makes very much sense. We've been working with vertical shifts all year, and you've been doing it since Math 1, and that's what it does, right? If it's positive, it's going to make the graph go up. If it's negative, it's going to pull the graph down. And a vertical shift also tells us our midline. So here's some new terminology for us. Midline. Can you say midline? Midline, very simple. And the equation for the midline is y equals k. So whatever this k value is here, that's going to be our midline. That's going to be where our trigonometric function, sine and cosine, is centered at, okay? And we've been doing examples. To give you an example, we've been graphing sine and cosine thus far, and our k values have always been centered at 0, right, or on the x-axis. That's been our midline, right? Kind of been the center of our graph. Well, we're going to change that today. But let's get back to writing some equations and just adding in this new information. So they say write an equation of the sine function, okay, and they tell us we have a midline of -1 and an amplitude of 3. Okay, so I know our functions are y is equal to plus or minus a times the function. It could be sine or it could be cosine, theta plus k, whatever it is. Okay, so I'm going to go ahead and fill this in. So our function is going to be y is equal to, okay, here's our a value, our amplitude, 3 times, okay, I have a sine function, so sine theta plus k. This is our midline, minus 1. And that's it. Very, very straightforward, very, very easy. All right, second example. Write an equation of the cosine function with a midline of 5 and an amplitude of -2. Okay, so midline is 5. That means that k is equal to 5 and an amplitude of -2. That means a is equal to -2. And it's very, very easy, right? Amplitude, our a value starts with a. Okay, so that's how I always remember it. That's how I know it goes out front. Y is equal to amplitude of -2, -2, okay, times cosine theta, okay, plus our k value, or our midline, which is 5. And there you have it. So that's writing equations with amplitude and midline. Here are some practice problems. Please go ahead and try these. Please pause the videos, and then I'm going to show you the answers. All right, so hopefully you have given these a go, given these a try. All right, and then here's your answers, okay? So amplitude is 12, midline is 10, and there's an error here. They say a midline of 10, so this should be plus 10. Unless they wanted it to go down, then it'd be -10. Okay, and there you are. Those are the 2 examples. Okay, here's another 2 practice problems. Please go ahead and give these a try. All right, hopefully you have tried these. Here is the solution. Okay, and there is the answer. All right, what I want to get into now is how do we graph sine and cosine functions with this new information about a midline? Well, here are some steps that I've kind of outlined. I don't believe they're in your notes yet. You may have them, but I know for my group here in 2020, the coronavirus generation, I know that you guys don't have these in your notes. I just added these in, so please write these down. Step 1. Determine amplitude and midline. I have to know, okay, what is A, what is K? So we'll write those down. A is equal to blah, K is equal to blah, right? And that's your midline. Step 2, you want to go ahead and graph that midline. I always use that first. I always graph that first, and then that's always my starting point. Step 3, determine the starting point or the location. So if I am sine, I'm going to start on that midline. If I am cosine, I'm going to start at the top of my amplitude, and we'll look at some of this. Step 4, determine your ending point, or kind of like where your period ends, or the cycle ends. I need to replot that point. Step 5, split the graph into quarters and place appropriate points. And then step 6, draw a smooth curve, right? You don't want to connect the dots. It's not like a spiky graph, right? It's smooth. It's oscillating. It's like waves. They're literally waves, right? Okay, so let's go ahead and look at our first example here. And it says, all right, so for this problem, they want us to graph y equals sine of theta plus 2 for 2 periods. So again, the step process that I recommend is first identify your amplitude, and your amplitude is going to be equal to the absolute value of A, which in this case is just 1, right? I have a multiplier of 1 out front, and then I'm going to go ahead and identify the midline, and the midline is your K value. So y equals, and this value, our K value is 2. So y equals 2. There's our midline. Okay, and what that does is going to vertically shift our graph up. So what I'm going to do is I'm going to kind of scale this. So 1, 2, 3, 4. And we are going to have a midline at 2. So I'm going to put a dashed line here at 2. And I recommend making it dashed. Don't make it a solid line. This is just kind of like a imaginary reference line. Okay. So I have my amplitude, I have my midline, I've graphed my midline. Now I need to know, okay, what is my starting point for my graph? Well, I have a sine function, and sine functions, if you remember, they started at the origin, at 0, 0. Well, really, they started on the midline, and so in this case, since we had a vertical shift up 2, my graph starts at the midline, okay, and then it's also going to end, okay, on the midline. So since my period is 2 pi, okay, here's my starting point and my ending point. Now what we need to do is we need to go ahead and split the graph into fourths. So I'm going to cut my graph in half, okay, and then cut it again into halves, all right? And then each of those locations, right, is the location of a significant point. So I start at my midline, okay, I'm going to go up to a maximum, and my amplitude is 1, so 2 plus 1 is 3. Okay, then I'm going to go back to my midline, okay, and then I'm going to go down to a minimum, again, so 2 minus 1, right, minus the amplitude, here's the minimum, and I'm back at my ending point. So here's what the graph looks like. Okay, and that is just one cycle or one period. What you need to do is you need to go ahead and do the same thing. They want 2 periods. So every 2 pi, this repeats. So I'm going to go backwards, 2 pi, and again, I'm going to split it into fourths. Okay, and then kind of repeat the pattern. So I had a max, a midline, a minimum, a midline, a max, and then a midline, right? And so here is our graph, okay? And there it is. All right, here is a second example. Graph y equals -2 cosine theta plus 2 for 2 periods. Okay, so what I want to do, again, is I'm going to identify the amplitude, which is the absolute value of A. Okay, so I have an amplitude of 2, and I am going to identify now my midline, which is my K value. So midline is y equals K, so 2. Okay, next I'm going to go ahead, I'm going to graph my midline. So you need to determine your scale. I think if I just, again, you go by ones, everything will fit. I have a midline at 2. Here's my dashed line. And then my amplitude is 2. So I know that my maximum is going to be 2 plus 2. Okay, that will take me to 4. And then 2 minus 2 take me to 0. So it looks like I'm good. Okay, now I need to go ahead and determine, okay, where am I starting? Well, again, my function is cosine. So note that a cosine would start at its maximum, right? Its first point is at a maximum, right? So here's my midline. My amplitude is 2, so it's going to take a maximum to 4. But my A value is negative, right? And this is going to flip my graph, or cause a vertical reflection. So instead of starting at a maximum, I'm going to start at a minimum. Okay, so I'm down here. Okay, and then my period is going to repeat again every 2 pi. So 2 pi and 2 pi. Okay, so here's my starting and ending points, and then I need to split the graph into fourths, right? So split, split, split. All right, I cut it in half, and then I cut each of those halves in half. That's what I'm doing. Okay, so I have a minimum. Okay, then I'm going to go to my midpoint. Then I'm going to go to my maximum. Then my midpoint. And then, again, my minimum. Right? And cosine, if you start at a maximum, halfway between you have a minimum. If you start at a minimum, halfway between you have a maximum. And that's kind of just the way that this function works. So here is the graph. And notice that my graph is kind of smooth, right? It's not connect the dots, right? I'm rolling through this. It's like a wave, right? Okay, not connect the dots. All right, so there's the second example. I do have some examples for you. Here is a practice problem. Please pause the video and try this example. All right, hopefully you paused it. Here is the solution. you have an amplitude of 2 and a midline of -1. So you shift down 1, and then your maximum is 2 units up, and your minimum is 2 units down. Now it's a sine function, right? So where do we start? Well, we're going to start on the midline at -1. Okay, and then instead of going up, right, I have a flip, I have a reflection. So I'm going to go down to the minimum first. All right, here is another practice problem. Please go ahead and try this one. Okay, hopefully you pause the video. Here is the solution. Okay, cosine function. So you start at a maximum. Your midline is at 1 with an amplitude of 2. So I'm going to start at, here's 1 and then go up 2. So here's your first point, right? I'm going to end here, and we'll split it into fourths, right? So split, split, split. And we get mid, min, mid, max. All right, I have, I think maybe 2 more examples for you. Here is this one, so please write this one down. It says graph y equals -4 sine theta -2 for 2 periods. So in this case, I have an amplitude, absolute value of -4, which is 4. Okay. The midline comes from our k value. So that is y equals -2. Okay, so if this is -1, -2, -3, -4, my midline is going to be here. But I'm going to go ahead and stop because notice my amplitude's 4. So I have to go 1, 2, 3, 4. And you see how that takes me off the graph? So what I'm going to do is I'm just going to adjust my scale. I'm going to say, okay, this is -2. This will be -4, -6, and this will be -8, right? 2, 4, 6, 8. Who do we appreciate? Trig. Okay, so then our midline is at -2, which is here. My function, right, is a sine function, so I'm going to start on that midline. Okay, and I'm going to repeat every 2 pi, and I'm going to split this into fourths. So kind of make those little cuts just to know, okay, those are my key points. And notice my a value is negative, so that's going to cause me to flip. So instead of going up to a maximum, I'm going to go down. Okay, so my next point is going to be a minimum, and my amplitude's 4, so I have to go down 4. So 2, 4, 6, okay, and it's right here. So there's my minimum. Okay, then back to the midline. Okay, then I have to go up to my maximum, so 4 up, and there's your graph. Okay, we do need to repeat it, so I will do that. And there you have it. There's that example. Okay, here is the very, very last example, and then I have one practice problem for you. It says graph y equals 3 cosine -4 for 2 periods. Okay, so I know that the amplitude is 3, and I know that the midline is the k value, y equals -4. Okay, so again, due to scaling, I'm just going to go by 2s. So -2, -4, -6, -8, and this would be 2. My midline is at -4. So here's my midline. Okay, and I have a cosine function. So I'm going to start at a maximum or a minimum, depending upon the a value. The a value is positive, so I'm going to go up to my maximum, right, from my starting point. So I'm going up 3. Okay, so -4 plus 3 takes me to -1, which based upon my scale is going to be right here, between 0 and -2. Okay, and I will end at that location. So I'm going to go ahead and split that in half, and then split each of these halves in half to know, okay, those are where my critical points are. So I'm at a maximum, midpoint, My minimum is going to be 3 down, so that'll be -7. Okay. And voila, there it is. Okay. And here's the second cycle. Okay, and there it is. All right, here's the last practice problem. Please pause the video, go ahead and try this example. All right, hopefully you have done this one. Here is the solution. Midline at 2 with an amplitude of -3, or sorry, amplitude of 3, but you're gonna be going downwards, right? Because it's negative. All right, that does it for this video. Remember, the objective was to be able to find amplitude and midline of a given function and graph them, as well as write equations given amplitude and midline. All right, until next time, peace out.